Hi, everyone. My name is Fred Martin. I'm an Associate Dean in the Kennedy College of Sciences at the University of Massachusetts Lowell.
And I am Deborah Seahorn. I'm a former Computer Science Teachers Association chairperson, and I am the lead at the North Carolina Expanding Computing Education Pathways. Today, Fred and I are going to talk to you a little bit about how we are planning to teach AI across K-12 education in the United States. Our mission of the AI for K-12 initiative is to develop national guidelines and also to develop a curated AI resource directory for K-12 teachers and to foster a community of K-12 AI resource developers.
As Deborah mentioned, we represent the AI for K-12 Guidelines Initiative. The two of us are two of the four members of the steering committee which founded the project. The chair of the project is Dave Turetsky, faculty member, Carnegie Mellon, and the co-chair of the project is Professor Christina Gardner-McCune, who is at the University of Florida. The project was joined by a working group, which was composed primarily of K-12 active teacher practitioners. And that's essential to our process, is that it's guided by teachers who are in the classroom working directly with their students.
As you know, the AI for K-12 initiative divided AI content into 5 big ideas as a way of organizing this framework for K-12 students. The big ideas are enough to cover the richness of the field, but small enough to be manageable by teachers because everyone can remember 5 big ideas.
So we're now going to be reviewing the big ideas one at a time and giving some examples of what students should be able to do based on this knowledge. And then we'll be giving some larger principles for bringing AI into the K-12 world. So the first big idea is perception, the idea of computers perceiving the world using sensors. And so our short statement of his perception is it's not only the receiving of information, but the extraction of meaning from the sensory information. And so what should students be able to do to represent this knowledge of big idea 1 on perception? So you can see there's a number of things on this slide. We're just going to focus on at each grade band 1 example. So for instance, in grades K through 2, which in the United States is ages 5 to 8 years old. Students should be able to identify sensors on computers, robots, and many appliances now have sensors on them. At grades 3 to 5, students could build an application that uses perception. For example, with the Scratch programming environment, and there are plugins that receive sensor input. At grades 6 to 8, students could explain that perception systems combine information from multiple sensors and use multiple algorithms to do so. And at the high school grades 9 through 12, students could understand that in perceiving sound, there's this idea of a homophone. Those are 2 different words that are pronounced the same. In English, there's many examples of this. And so in order for computers to disambiguate what word is spoken, they need to draw on the larger meaning of the sentence.
Big idea 2 is about representation and reasoning. The statement that describes that is that agents maintain representations of the world, and they use those representations for reasoning. Again, as Fred did with Big Idea 1, we'll just highlight a few of the things that students should be able to do when they're learning about Big Idea 2. In the lower grades, K through 2nd grade, 5 to 8 years old, students should be able to draw a map of their classroom or school and compare the map to the actual room or school building and grounds. In the next grade level, from grades 3 through 5 or 9 to 11 years old, students should be able to create or design a representation of an animal classification system using a tree structure. Grades 6 through 8 should be able to design a graph model of their home or locations in their community and apply reasoning to determine the shortest path to key locations on their map. And the high school students, grades 9 through 12, should be able to draw a search tree for tic-tac-toe.
Big idea 3 is about learning. that computers can learn from data. So this is also the whole realm of machine learning. So at the primary level, grades K through 2, students can learn from patterns in data with unplugged activities. So an unplugged activity is activity that doesn't use technology. It just uses perhaps paper and pencil or students' own bodies to move around the classroom, and recognizing this idea of patterns. At the next grade band, grades 3 through 5, students can modify an interactive machine learning project by training its model. For example, there's a system called Machine Learning for Kids that was developed in the UK. It's based on Scratch, and it allows students to actually build and train machine learning models. At the next grade band, grades 6 through 8, students are introduced to the idea of bias. So the idea here is that a training data set will only train the system based on examples in that data set. And so if the data set is limited, then the system will be biased. So students can extend the training set to address bias. At the high school, grades 9 through 12, students can learn about neural nets by training a neural net using an online tool called the TensorFlow Playground.
Big idea 4 is about natural interaction. And the statement that describes that is that intelligent agents require many types of knowledge to interact naturally with humans. And humans are among the hardest thing for AI agents to understand. A few things students should be able to do. The youngest students, grades K through 2, should be able to recognize and label facial expressions into appropriate emotions, such as happiness, sadness, and anger, and explain why they have labeled them the way they have. The next grade level, grades 3 through 5, students should be able to identify how humans combine multiple inputs, including tone, facial expressions, posture, etc., to better understand communication. Grades 6 through 8 students should be able to construct a simple chatbot. And the high school students in grades 9 through 12 should be able to identify and debate the issues of AI and consciousness.
Big idea 5, the final big idea, is societal impact. And this idea in the graphic that we showed earlier it connects with all of the prior big ideas. And the idea is that AI can impact society in both positive and negative ways. So in the youngest grade band, students should be able to identify common AI applications they encounter in their daily lives. At grades 3 through 5, students can describe the way that AI systems can be designed for inclusivity. At grades 6 through 8, students can, and this is really building on the prior grade band, can understand trade-offs in the design of AI systems and how decisions can have unintended consequences in the function of the system. And at the high school grade band, students should be able to design an AI system that addresses social issues, or they might explain how AI can be used to address a social issue. So this is putting into practice their knowledge about AI.
One of the things we would like to share with you is what we have started to do with the AI for K-12 initiative in order to be able to expand AI education, AI K-12 education throughout our country. We have 50 US states, and each state has their own system of public education for grades K through 12. There's some differing levels of central control in each state, but it's essential that each state plan its own method to implement K-12 AI education. Last January, we held a 2-day workshop called the State of AI in the States workshop, and it was a virtual workshop because we were in the middle of the pandemic. But we had general sessions, and then we had breakout sessions where each state could meet with the people that were representing that state and set their own vision for implementing AI and start planning what they needed to do to be able to implement AI. Since that time, we've had regular check-in webinars, 3 months, 6 months, and 9 months from that date. at which time the states share what they have done with all the other states. And then we break out into collaborative breakout sessions about different topics, which is greatly enhancing the communication among the states. And because we check in regularly, the states are kind of held to a standard to know that they need to get work done, and it keeps us all on track. You can find more information about this at the URL that's listed and the last bullet on that slide. I wanted to share with you what 3 different states are doing. One of the states, California, is a very large state, and they have their little logo up in the top of this slide in the right-hand corner. And they're doing many things. They're focusing on awareness, community, and accessibility. But the first thing they did under awareness is they drafted a getting started guide to help the districts know what they could do to get started with AI education in the K-12 system. In the community, they were identifying how to leverage future industry partners and reach out to potential industry partners who would join them on the journey. And for accessibility, they're creating a crosswalk among the 5 big ideas in AI and their state computer science standards and other core subject area standards. Next slide. Georgia, a medium-sized state, has created an AI pathway that's been approved by their State Department of Education, and they have a grant. Their pathway has 3 courses for students in high school. Maryland is also a medium-sized state, and they're doing quite a bit in AI education, and they've noted several things as they've done their work. First of all, AI is an excellent entry point into computer science for diverse subject areas. Secondly, the math monolith appears to be shifting to more consideration of data science. And then they want to know how they can create a skills progression for computer science that includes AI, cyber, and data science. And they said the challenge of communication is that understanding AI is integral to understanding how our world works. And their goal is to educate an informed citizen. A few other things Maryland is doing, just to highlight a few. They're planning a state symposium to include K-12 and higher education. They're planning a middle school pilot this year, and they're piloting an AI and English language arts course. And they have over 50 high school English teachers who have applied. They are also developing an AI learning pathway for teachers, recognizing how important professional learning is for the teachers.
Thanks, Evra. So we're going to now share some bigger picture guidelines about how to support K-12 students. So for example, we want students to understand that AI isn't magic, that it is code going on. There's technology behind the scenes. And so there's this idea of a black box system is where you give it inputs and it produces outputs, and you can't see what's going on the inside. A lot of technology works that way. We want to build transparent, like clear boxes, so that students can see what's going on inside the system, they understand how it works. That will help students build mental models of what's going on underneath the hood inside an AI application. So we want these systems to illustrate how they work. By the way, this is at the research level of AI. This is also a critical research area that we want to know how AI systems are working for our own understanding. So it's also true for education. And the third item, we want students to develop their own AI applications using AI services. So we mentioned earlier the machine learning for kids system that's developed by the UK. That connects with IBM Watson on the back end to do the machine learning training and modeling. And so lots of AI systems use libraries that are easy to use. The library APIs have been made very user-friendly, and we want students to be building their own AI systems. So here are more considerations about student activities. So again, it's all about students interacting with AI. So we want them to experiment with AI agents to investigate their behavior. So many families in the United States have Amazon chatbot devices. And so those can be brought into schools, and students already, they come into school, many students, having a lot of practice interacting with AI agents. So that's something we want to encourage. I already mentioned we want students to build their own AI applications. That's really important. And the third point here is we want students to explore case studies of how AI has impacted society from multiple perspectives. So positive outcomes and outcomes we should be worried about both together, because we want students to be able, when they finish school, to be informed citizens, that they can understand AI and they can choose to be AI developers.
Understanding perfectly that K-12 teachers need to have resources and activities to be able to teach AI to their students. We pulled a few activities here that you might find interesting. The first is a video that explains how AI is used by robots, and it examines the fictional robot Wall-E from the movie. And the video link is there. It was developed by 3 women in the robotics PhD program at Carnegie Mellon. Next is a glossary for beginners developed by the CompTIA Artificial Intelligence Advisory Council, and it's a comprehensive list of words and phrases and definition. Next is a Google post that shares all their top 15 projects that use AI when they power the Google products. There are many more resources on the AI for K-12 resources page, and the link is there for you. And if you're not already aware of it, there's an AI for Teachers community website called AI for Teachers, and the link is there. And lots of collaboration by teachers is going on. This is just a small sampling, but we want teachers to know that there are resources out there and there are people out there to help them.
So this rubric was shared with us by the organizers of your conference, that in your country, you're going to be bringing AI into your computer science, digital literacy, and computational thinking curriculum from K through 12. So at a national level in your country, you've already made the decision to make AI happen. As Deborah was explaining earlier, in the United States, it's much more of a distributed system where each state is embarking on the same process. And I think one way of thinking about that is there are a number of states in the United States that are as big as or bigger than a whole country. So the US is the way it is because it is so large, and because of its history of distributed control. So you're ahead of us in that you're taking this step at a national level. So we're really excited for you. And yeah, we have a few closing thoughts. Next slide.
So just a few words of wisdom that we have learned as we started our journey. Make sure that you provide extensive and ongoing professional development opportunities for teachers, and make sure that those opportunities are collaboratively led by teachers. Teachers learn best from other teachers. Be sure you rely on teachers' knowledge about what is possible to teach and when, what age groups, and so forth. And when you're working on creating learning progressions, that is imperative. Make sure you explore cross-curricular connections between AI and other disciplines. We know that California had started to do that in their state, but it's important for everyone to do it. And build a community of teachers to share experiences and effective practices so everyone can work together and learn from each other. Now the fun begins. Bring AI to your teachers and students. Our website is listed there. If you don't already belong to our mailing list, send an email to the email address there so that you can join. And you'll get lots of information shared almost daily.
We'd like to acknowledge our supporters for this project. So the AI for K-12 initiative was launched by collaboration between the AAAI, Association for the Advancement of Artificial Intelligence, which is an international organization, and the Computer Science Teachers Association, which is also an international organization. We've had funding from the US National Science Foundation, and the program is listed there. And the Carnegie Mellon University also provided support for this project. That's the end of our presentation. Thank you so much for being with us today. Thank you.
Thank you.